Hello everyone, welcome to Jason's Math Studio. In this video, I'm going to talk about the second derivative. The first derivative is a gradient of the curve f of x, and the second derivative is a derivative of the first derivative. So, the second derivative is a gradient of the curve f dash of x. If the first derivative is positive, we can conclude that f of x is an increasing function. If the second derivative is positive, we can conclude that f dash of x is increasing. Now, here is a graph, and there is a point on the graph, point A. We draw a tangent line that passes point A, and the gradient of the tangent line is denoted as m. Now, the gradient of this tangent line is -2. I'm going to change the value of A, and so point A will move along this curve, and pay attention to this value, see how the gradient changes as point A moves along the curve. You can see that m is increasing, which means the gradient of the curve is increasing. So we can conclude that f dash of x is increasing because f dash of x is exactly the gradient of the curve. And it tells us that f double dash of x is positive, and the shape of this graph is concave upward. Now, let's consider another example. The gradient of this tangent line is 2. Now, A is going to move along this curve and see how the gradient of the curve changes. You will notice that the gradient of the curve is decreasing from a positive number decrease to a negative number. Since m is decreasing, that means f dash of x is decreasing, and f double dash of x is negative. The shape of this curve is concave downward. From these two examples, I want you to know that the second derivative corresponds to the concavity of the graph. It measures the rate of change of f dash of x.